Jacob Berkowitz, you're here as the Baruch S. Blumberg NASA Library of Congress Chair in Astrobiology, Exploration, and Scientific Innovation. Here at the Library of Congress, you're diving into a life, and I want to talk to you a little bit about what it is to write about science, making it accessible to non-scientists, and what it is to write biography. So let's just dive into the story that you're exploring and see where we can go with it. Paul Merrill is the name of the astronomer. Who was Paul Merrill?
I like the way you said the dive into a biography. That's what the experience. I've been working on this biography for the last 12 years. So maybe deep diving and swimming would be the way to describe it. So who was Paul Merrill? Well, I've gotten to know him even though he died about 60 years ago. He is a largely forgotten but remarkable person who was one of the major American astronomers of the first half of the 20th century. And my research has shown that he made the key discoveries that document our stardust origins. The fact that if we think about what I call extreme genealogy, so if we think about our family story, it actually extends back to stars. And so when Carl Sagan famously said, "We are star stuff," he was in fact standing on Paul Merrill's shoulders, though I don't think from my research that he actually knew this. So just to put Paul Merrill in a little bit of context, he was born in 1887 in Minnesota, and he dies in 1961 in LA. So he lives from the first vehicle he traveled in was a horse and buggy. Like his parents, I think he was born at home, but when he went for a trip, it was in a horse and buggy. And he dies just as the second American goes into space. So he lives between the horse and buggy age and the space age, this great age of kind of innovation and advances in science. And I guess the last piece I'd add in just terms of who Paul Merrill is kind of the greatest observatory in the world in the first half of the 20th century was the Mount Wilson Observatory, which is a vertical mile above Pasadena, so just outside LA. And in January 1919, 2 astronomers were hired there. One was Edwin Hubble, who a lot of people know for the Hubble Space Telescope, the discovery of the expanding universe, and the other was Paul Merrill.
Edwin Hubble I've heard of. I'm assuming
yes.
Biographies have been written of him. Paul Merrill I had not until I learned about your work. Why did you think it was important to write a biography of him, not just about a particular scientific discovery or something, but to actually write his story?
Yeah. So I've been popularizing science, largely focused on popularizing the science for the past 30 years as a science writer, as a science popularizer. And often when I interview scientists, I become more. I want to tell more of their stories. One of the core techniques in popularizing science is to use the scientist as the protagonist in the story, because often the science is complex, and how do you bring people into it? You bring readers and viewers in through the personal connection to the scientist and their sense of wonder or discovery. So I was writing a history of astrobiology. And astrobiology is the amazing integration that's happened in the last 50 years between biology and astronomy. And it's trying to understand life, the origins of life and the distribution of life in a cosmic context. So I was writing my book, which is called The Stardust Revolution. And as I was, one of the kind of core elements of the field of astrobiology is the origin of the elements and the fact that most of the elements that are around us now, other than hydrogen and helium, are all formed in stars. So as part of that research process, I was talking to a current astronomer who works at Mount Wilson. and he said, "Do you know Paul Merrill?" And it was like one of those moments, where it's kind of like I remember, first seeing the person who would become my wife, and I remember the moment. It's like, "Do you know Paul Merrill?" I'm like, "Paul Merrill who? Like, I never heard of this guy," or have most people. And he explained to me that Paul Merrill's research was central to the Stardust story because one of the key discoveries that enabled astrophysicists to realize that most of the elements are made in stars was the discovery of a short-lived radioactive element in the stars. It's called technetium. And if anyone's ever had a heart stress test, technetium is used in heart stress tests because it has a very short radioactive life. It decays into something that's not radioactive after a very short time. So Paul Merrill discovered this element in a star. And the nuclear physicist realized that, if this short-lived element is in a star that's hundreds of millions or billions of years old, it means the star is producing it. So this was a critical insight. So long story short,
Walk me through two things.
Yeah.
You mentioned that hydrogen and helium are out there, but
Yeah.
stars form all the other elements.
Yeah.
Tell us a little bit about how that happens, if you can. Do your science
Okay.
popularizing. And second, when you say that Paul Merrill discovered technetium in the star, how did he do that? He's obviously not traveling. He's right here at Mount Wilson.
Right.
What's the process?
Excellent questions, which were dominant questions in astrophysics for 100 years before they were discovered. So one of the things about thinking about if we think about the history of the universe, one of what for me is the mind-blowing things is that in the very beginning there were no stars, there were no planets. The only elements produced in the Big Bang, so the very beginning of the visible universe, like 13.8 billion years ago, approximately, were the elements hydrogen and helium. So if you remember your periodic table from high school chemistry class up on the the front of the room, hydrogen on the top of one side, helium on the top of one side. They're the simplest elements. So the big question was, at that time, like let's say 1920, 1930, even 1940, they didn't know this. So the question was, were all of the elements formed at the Big Bang? So we know there's iron, carbon. We're mostly like carbon and oxygen. You think breathing in nitrogen. Where did all these elements come from? And Paul Merrill is studying very cool stars that are so cool that physicists really had a hard time understanding that you could have a star whose atmosphere was it's in Celsius, 2,000 degrees Celsius, but temperatures that you would have like on blast furnaces on Earth, like, where you make steel. So Merrill was a very quirky guy, and he was drawn to studying the stars that were the outliers. And these stars, these very cool stars, they were red. Like if you imagine your charcoal, having a campfire. Campfire at the very beginning is burning like you'll see blue and white. It's very hot. The embers at the end are red. They're actually cooler. And he was interested in studying these giant, cool stars. And it turns out the reason that they're giant and cool is they're expanding. They're essentially pulsing. And they're pulsing because they're dying. They're producing elements, and as they produce elements, they're heating up, and then gravitationally they're contracting. And these stars are known as red giants. Our star is going to become a red giant at the end of its life. And the observation of technetium in its atmosphere was the clue that the energy that was causing it to expand and contract was nuclear fusion reactions that were happening in the star's core.
The nuclear fusion creating these elements.
Creating these heavier elements. So in our star, we only have, in our sun, hydrogen is being fused into helium, but the not heavier elements. So now the question was, you asked,
how does he observe it?
How does he observe it? Okay. So let me kind of take it into a historical context. One of the things that's been really interesting for me in writing or doing the research so far and beginning to write the biography is thinking about historical context and timing, where and when someone is born. And Paul Merrill is born like in 1887, to come of age as a scientist at this like incredible point in the science of what's called spectroscopy. So if you think about the rainbow, so we go from blue to red on either side of the arc of the rainbow. And if you take sunlight through a prism, if people have prisms on their porch or something, or window prism, you'll see that you see a rainbow, essentially the same arc coming through the prism. Now, if you were to look at that light with a microscope, in any prism that you see the rainbow, the spectrum of the sun produced, you would actually see dark lines. And if you could look really carefully, you would see thousands of dark lines. And this was one of the great mysteries of physics in the 19th century. What's causing these dark lines? It turns out the lines are essentially the fingerprints of the elements that are in the stars. So spectroscopy enables astronomers to see what stars are made of. And Paul Merrill was a spectroscopist. And at just the time when the intersection of photography, big telescopes, and spectroscopy kind of came together. So he could look at faint stars that were far away and still get enough light to look at what elements were in them.
Amazing.
Yeah.
You mentioned you had never heard of Paul Merrill, and you've been working in this
Right.
field for some time. I've gathered in discussing this with you that there's never been a biography of him.
Right.
What kind of challenges does that create? Coming from my own field of study, I know there are hundreds of biographies of a Thomas Jefferson or a George Washington, and one could start preparing a biography by reading other biographies.
Right.
This is different.
Right.
Talk to me about that challenge.
Right. So one of the keys was finding his granddaughter, who's still alive, Kate Merrill. And she has been enormously helpful and generous, and it's become almost a team effort in terms of, for her to understand her grandfather, and, for me to begin to understand her grandfather through her. So in terms of the challenge, there were maybe, when I began the project, a half dozen people who had known Merrill personally. And I was able to interview, I think, all of them. And that was important. I think the other, I think one of the challenges that I take very seriously is the question of the angle that I take. As writing the first biography of someone, how do you describe what they did, particularly in a case when he was a very, very private person who didn't want to be known. The way I think about it is, the challenge for him as a scientist, he wanted to know, but he didn't want to be known. So this gets back to the challenge of, I'm looking for any little piece of evidence that he leaves in a letter, or, he didn't keep journals, but he did. His wife left a short personal biography. So any little details that I can find, I have to both interpret and attempt to extrapolate.
Why didn't he want to be known?
This is one of the most interesting things that I found, and what's really intrigued me about writing about Paul Merrill. So both his father and his grandfather had been congregational ministers. And as a young man, he grew up in the shadow, he grew up in what's now Silicon Valley as a teenager, in the shadow of Mount Hamilton where the Lick Observatory was. And at the time, the Lick Observatory was one of the, had one of the largest telescopes in the world. So it was kind of like, imagine if you grew up beside kind of Cape Canaveral, it's at the very beginning of the space age, and you were like, oh yeah, I want to be an astronaut. For Merrill, it's like, oh, I want to be an astronomer. The challenge was, in terms of becoming a scientist, he grew up in a family culture and in a certain, perhaps could even describe it as a religious culture, in which the worst thing to do was to shine the light on yourself. The worst thing to do was to be the tall reed. And I don't know, his granddaughter said that, it was very clear to her he was a very enormously private person. His daughter-in-law lived with the Merrills, so Paul and Ruth Merrill Ruth Merrill was his wife, lived with them for 2 years and said they never shared anything about their childhoods, about their pasts, that the dinner conversations were very formal. So it was a personality element to Merrill that he didn't for some reason want to be known.
You've mentioned Edwin Hubble, these two men that worked side by side at the Mount Wilson Observatory. Hubble is now, in some ways, a household name because of the telescope, if nothing else. Very different men. Were there similarities that you've been able to come across? How do you connect Merrill and Hubble besides the fact that they shared a telescope?
Right. So one of the things that really, so to go back to, why did I want to write a biography of Merrill? So when this will be a long-winded answer to your, and just bring me back if I get too far out there into the universe. Two things, like when I was like, oh, is there something more to say about Paul Merrill here? There was a little anecdote that had been written about him in the history of the Mount Wilson Observatory, like 3 or 4 pages. And in the footnotes of that, it was a former director of the observatory who wrote it. He said, I just want to share a couple of little anecdotal bits. And he said, Paul Merrill and his best astronomy friend would go down the street to the Wren restaurant for lunch for 20 years. And in even-numbered years, Paul Merrill would have the peanut butter sandwich and Alfred Joy would have the cheese sandwich. And then in odd-numbered years, they would switch. And I thought, okay, these are we've got our odd couple. This guy is particular. And then the other fact was that he was, we talked about him being enormously self-effacing, even with his colleagues. His colleagues were one of his colleagues teased him that he was the man who knew too much because, when anyone asked him what he thought, he would say, don't ask me, ask the stars. He would just completely deflect kind of authority to go and observe for yourself. But there was one person that really got under his skin and that he visibly hated, and that was Edwin Hubble. And one of his in this history of the Mount Wilson Observatory says that he would darken over like a storm over the prairies when he was in physical when he was in the same room with Edwin Hubble. And part of the reason is that Edwin Hubble was the exact opposite of Merrill in terms of their kind of social dynamic around attention. Edwin Hubble was a huge attention seeker. Everyone knew this. He had gone to Oxford. He came back. He maintained a kind of Oxfordian accent. He was enormously handsome. People would come to Mount Wilson. This was the time, just the beginning of Hollywood. So he hung out with all the actors, with the famous people in Hollywood. People would come to the observatory to visit and, remark on his kind of Apollo-like appearance. And he would really work it. He would be at the telescope with his, with his pipe. And he would write articles that said, as Hubble has discovered or as Hubble has seen. And so for Merrill, it was the antithesis of how to be in the world. And so, the contrast between their two stories and the fact that Hubble's discoveries Hubble's discoveries of the fact that the Milky Way is not the entire universe and that, in fact, the universe is expanding was really the great discovery of the first half of the 20th century. I mean, perhaps in all of science may be an exaggeration, certainly in astronomy. And so when I went to Mount Wilson to visit, all of the public education materials are related to Hubble and the discovery of the expanding universe. And I thought, where is the discovery of our stardust origins? This is a profound discovery, to realize that we are physically connected to stars. Stars are really not in any kind of fantasy or magical sense. Stars are our ancestors. And where is this story at Mount Wilson? Particularly because the founder of Mount Wilson was George Ellery Hale, who was kind of the greatest telescope builder in, I think, all of human history. And what inspired him to build, in 3 successive telescopes, the largest telescopes that had existed until that time? It was because he was totally inspired by Charles Darwin and wanted to extend concepts of evolution into a cosmic context. Extend it beyond Earth and think about evolution in a cosmic context. And it was, Hubble laid out the geography of an expanding universe, but it was really Merrill who kind of made the key observations that begin to kind of give us the groundwork for thinking of our relationship to the cosmos in an evolutionary concept, in the sense of increasing complexity, going from hydrogen and helium to these more complex elements.
I think you may have already begun to answer this question I have for you, how writing a biography of a scientist is different from writing a biography of a Thomas Jefferson or some such person. Part of it is having to grapple with challenging scientific discoveries, concepts, the sort of the base level physics and chemistry that one needs to understand to make sense of Merrill's discoveries. But how else? How is writing a biography of a scientist a unique challenge?
The first challenge is to explain the science, particularly when it's not a science that's readily accessible to folks. I mean, if you're talking about biology and something we can, feel the gut biome or our brains, we all, we can kind of relate to that more quickly. And I think it's easy for the person to be lost in all of the scientific detail. So I've really made an effort to kind of really try to understand Paul Merrill as a person.
Are there other biographies of scientists that have stood out to you as models of things to do, things not to do? What books have you read that are useful?
So I'd say 2 come to mind. One is a book called, and this kind of relates to Merrill in some ways, even in the title, called The Strangest Man, which is a biography of Paul Dirac, who was the theoretical physicist who discovered, whose theories predicted the existence of antimatter. So, before antimatter had been physically detected, his mathematics with quantum mechanics and general relativity predicted the existence of this.
He's living at the same time as
so this is in the 1920s. Yeah, so at the same time, yeah. And what I remember from that biography that just struck me so much is that he had a tortured relationship with his father. And his father was a French teacher and insisted that Paul eat dinner alone with him every night and only speak in French. And so Paul didn't talk. that was his way to survive these dinners. And he was an enormously quirky person. And another one of the kind of examples that stands out for me is he was giving a talk and had written something on the blackboard, and a student put up their hand and said, "I don't understand this part, Dr. Dirac." And Dirac stood silently. Time went by. He's just standing there, and the convener said, "Just Mr. Dirac, are you going to answer the question?" And he said, "There wasn't a question," because he just said, "I don't understand." This is the kind of quirkiness that we're dealing with. But this is someone who discovered antimatter, something that's completely not kind of nonsensical. So you begin to see these kind of parallels between, and the other biography is American Prometheus about Robert Oppenheimer, that the movie Oppenheimer is riffing on. Yeah. And it is, spectacular story. And I realized that why I'm interested in both of these biographies is they were physicists who were studying, and this is the basis of astrophysics and particle physics, is that it's the smallest and the biggest at the same time. You have to, when you're doing particle physics, you're thinking about the particles that were formed at the Big Bang. Before the hydrogen and helium, there were all of these subatomic particles that formed. And this is so Merrill is coming at these things in the same way. He's trying to that astrophysicists, and this is the kind of the beauty of the field, is that in order to understand stars, you have to understand atoms and elements. And in order to understand atoms and elements, you have to understand stars. And this is the space in which Merrill, I realize, I'm interested in Oppenheimer and Dirac because they were operating in the same terrain. And I guess it's a terrain that I just find fascinating.
Yeah. The individual personality that you describe with Paul Merrill, someone who doesn't want attention, that is apparently in every way focused on observation as opposed to disseminating that knowledge to the world. But surely he wrote. He's communicating these ideas somehow. Can you talk to us a little bit about the ways in which he did work to share his ideas? Is he a writer? Is he a good writer? Is he someone that's made an impact in his own time? Talk to me about that.
Okay, let me break that down into a couple of things. When I was in university studying biology, the cartoonist Gary Larson was really popular. And Gary Larson had a cartoon where it was like a series of panels, and it showed you, the scientist and what the scientist, he or she, studied. So, but the joke was that the scientist who studied slugs was like very slow moving, and the scientist who studied cheetahs was kind of like, very, very quick. And so he was making the observation that there is something between the personality of the scientist and why they are drawn to a particular field. And I was talking with one of my Kluge colleagues the other day had been a material scientist, and she said, "Oh yeah, like chemists are like this, and theoretical physicists are more like this." And Merrill was a spectroscopist. And why did that fit with his personality? Remember I said this is a guy who on 1 year would eat the peanut butter sandwich every day and then switch the next year. And he didn't want to be known, and he didn't want to draw conclusions. He didn't want to draw big conclusions, because this is the way to get known, right? If you say, well, I've made a big discovery, this is a way to kind of shine the light on yourself. So how could he both know and not be known? spectroscopy is the perfect field, because what you're doing is essentially solving like the ultimate crossword puzzle. So in these star fingerprints and so they're little, literally glass slides that are maybe, 5 inches long, 1.5 inches high, and they're just filled with all these little dark lines. There were also bright lines, which were like a mystery. What are these lines? And he was, star by star, solving these lines. What is the element? Because it's not as I got totally lost. But I think I answered the spectroscopy part, and you were the next. The rest of the question was
writing. How does he communicate?
Oh, how does he communicate this? So he's solving what are the elements in stars, and as part of that, what he is describing is because the elemental fingerprint depends on the temperature, depends on the pressure, depends on how quickly the element is moving. So what he's beginning to see is actually a picture of what is happening in the atmosphere of a star. And he's one of the first astronomers to begin to describe the atmosphere of a star, which is, when astronomers look at stars, you're trying to understand something by only seeing its surface. And yet the nuclear physicists want to know what's going on in the heart of the star. This was the great challenge. And so Merrill is unraveling this, basically kind of this stellar riddle, line by line, which means he's able to share information, and he shared a vast amount of information in papers. But all of the papers are, with titles like, a spectroscopic study of 20 S stars, in which he describes all of the things he observed in the S stars, and some little, very vague kind of concluding sentences. And, if you read the articles, he would never write like a review article. It was very difficult for him to write an article to say, well, this is what I've discovered looking at all of these stars, but I found this. So spectroscopy was perfect because it was enormously detailed. It was enormously repetitive, because what he wanted to do was look at the same star over and over and over again. And these red stars, they're variable, they're pulsing. So they're changing over time, and it's very rare. Like, most of the stars remain relatively static in their behavior. But I think that from my research, I think he looked at the same stars more than any other astronomer in human history. And he was able to describe what he saw in these enormously detailed papers that even the astronomers closest to him said at the time of his death, we're really not going to know what he discovered for decades, because he produced such a vast amount of observational data that at present we don't really understand what it is. And he hasn't been willing to say what he actually, fully thinks he discovered.
Has the data survived? You mentioned these glass slides, for instance. Are these things that exist as artifacts, and are they still relevant to scientists?
It's a really interesting question, the two parts of it. They do exist. They're in the basement in Pasadena, in the vault. The astronomers call it the vault, which has a vault, like a bank door. And I went to look at the slides that Paul Merrill had held, and actually hold them and look at the the stellar fingerprints. And for the astronomers there, so in terms of Paul Merrill, are they relevant? I went to the office in which Paul Merrill worked for 40 years and met the astronomer who now occupies that office. And he's like, yeah, nice to meet you. And he didn't know, he hadn't heard of Paul Merrill. Because astronomers are interested in the next big thing. Most are not interested in the history of astronomy. So it makes total sense that he didn't know, Paul Merrill, or like many of the other spectroscopists who had worked at Mount Wilson. But are they relevant? I think they are scientifically not, perhaps not so relevant.
Because observation has improved.
Yes, exactly. It has improved exponentially. Now we have space-based telescopes that are looking at stars with much higher resolution. But in terms of understanding the future of discovery, I do think they are very important, because one of the things I've learned through working on the biography is we create the past that we need in order to move forward. History is not what happened. It's what we remember. It's what we record and what we remember that happened. And we know that with other hidden figures, black women who worked in this, who are critical in the space program, that bringing those stories to light is important is bringing these historic stories to light is important to how we see what can be done today. And so what is the biggest search one of the key searches in astrobiology now is the search for another living planet. And this is I'm taking a windy road to get to the answer. Paul Merrill did not know what he was looking for. I mean, this is one of he did and he didn't, and this is the great, for me, the fascination of science and where it intersects with art and creativity. If you're deeply curious, you have to be open to discovering what you couldn't have imagined. So I think Paul Merrill knew that in looking at these quirky, red, cool stars, these outliers, that in fact and I have evidence of this from his, one sentence in letters and in articles. He was wise enough to know that the outliers said something fundamental about the non-outliers, about the nature of it was in the edges that you'll discover something fundamental. And we're now on the cusp of, 30 years ago, many astronomers thought there were no planets outside of our solar system. Maybe most astronomers thought there were no planets outside our solar system. And if there were, it was going to be impossible to detect them. And when the first exoplanet was discovered in the mid-1990s, it just created this explosion of possibility of there are planets around other stars. And now we know that there are more planets around other stars in the Milky Way than there are stars. So when you look up at the night sky, most of the stars that we see have other planets orbiting them. This is like the great revolution of our age. And so now the question are, do we build telescopes, more advanced telescopes, to look, in terms of astrobiology, to look for another living planet? And I think this is where, coming back to these, these little glass slides, that there is so much to discover that we cannot, imagine. And it's living in this place of curiosity and continuing to look. And interestingly, the core technology that's being used now by the James Webb Space Telescope to begin to look for other planets is technology that was pioneered by Paul Merrill. So most of what he did was looking at stars in the infrared. So in energy wavelengths, they're just below what we can see. So infrared means below the red. So if you think about that spectrum, it's the light that's below the red light. And ultraviolet is the light that's above the blue light. So the James Webb Space Telescope looks mostly in infrared. And that's what Paul Merrill worked on developing, basically photographic emulsions, like the chemicals that would capture infrared light. So that was a long-winded answer to say those little slides, I think, are totems to what's possible, in kind of moving beyond what people think is, the impossible. They're kind of totems to that possibility.
Have you come to know Paul Merrill as you've spent time in the surviving materials that he left behind? You've talked to people who knew him. Do you feel as if you're beginning to know more about Paul Merrill's personality? What made him tick? Is he still a mystery to you in some ways? Where does Paul Merrill stand in your study right now?
Oh, I appreciate that question. His favorite, that was such a great question, because the last sentence in his last book is about, I wouldn't say he was a devout Christian, but he was a Christian on some fundamental way. Not a fundamentalist, but I think he was a believer. And the way he kind of squared things with, the kind of these discoveries that some might see as outside of, he never felt that he needed to kind of hew to biblical truth, obviously. That the divine was revealed through his observations. But to get to your point about do I know him, his favorite kind of last line was, "We always need to leave room for mystery," which is kind of an out for me, because I can go, oh, okay, there has to, but so to answer your question, my father died 6 months ago, so while I'm writing the book. And it was both it is a very painful experience, and it has helped me enormously as I prepare to kind of really get into the writing of the biography, because in going through some of my dad's belongings, I realized in some ways I didn't know him.
Wow.
Here is someone who I lived with as a child, who I, talked to for almost 60 years. And yet when I go through his personal things, I'm like, I didn't know my dad was so interested in the question of life after death. He had 10 books heavily annotated, in that. And he'd never talked to me about that. And I began to think about his, I realized as an academic, he had only written 2 papers. And he'd been an academic for 30 years. An English professor, and he loved teaching, I knew, but I began to think, and I had some conversations with colleagues at the Kluge, I began to wonder, did he actually like his job? And I've talked to my mom about this a little bit, and so I think it has, do I know Paul Merrill? I know Paul Merrill better than anyone else on Earth, but I think it's shaped how I am going to tell his story, which is present the facts of what I have found about him. This is a person who loved repetition, who didn't want to be known. I mean, when I talked to his daughter-in-law, so I interviewed his daughter-in-law, and she said she first met Paul Merrill in 1944. So he was in his late, I guess he was maybe 50. And I said, what was he like? She said, well, he was a stuffed shirt. He was a really stiff,
From his daughter.
From his daughter-in-law. Meeting him. So she's, 20, and she's coming to meet him at their, at her boyfriend's home or fiance's home. And, he's very formal, shakes her hand. And I mean, some of the other things I know about him that I'm kind of sitting with is he had terrible osteoarthritis. He suffered enormously through his life, was often from his late 20s until he died in his early 70s. So 45 years, he would go through these bouts where his joints would swell so much that he would have to be in bed. And so I'm interested, I've written a little bit of, as about chronic pain and what chronic pain can do to the way that we think and to our personalities. And here's someone who sat as a spectroscopist. He would have to sit at the base of the telescope in the winter on top of this mountain, at Mount Wilson. It's below freezing. It can't be heated because that will distort the image. And this is a person with terrible osteoarthritis who would have to sit for 6, 7, 8 hours through the night, hunched over, keeping the light of a single star focused on the slide. And I'm like, what kind of person does that in chronic pain? So the other thing that I found very interesting about being in the Kluge and having scholars who are literary scholars and who are thinking about, one in particular scholar who I had a lot of lunches with was interested in kind of Freudian analysis and how Freudian analysis has shaped kind of literary scholarship. How can you know someone's Freud was interested in people's, we talk about childhood trauma now. This all comes out of, Freudian thinking. Sexuality, how does that shape someone's life? How much can I actually know about Paul? If I'm telling the story of an individual, their internal life matters. And this is someone who didn't share a lot of his internal life. And one of the things that's been, that brought a little smile to my face is I was thinking, I am doing with Paul Merrill what he did with stars. He could only look at, he could only get these little lines. He could put together this like enormous puzzle, and I'm putting together, and he could only see the outside of the star, and I'm trying to do the same. I'm trying to understand the inside of this person from the outside. So I feel like I have enough to write a good biography, and there will be parts that will remain a mystery, forever.
Perhaps there's no greater answer to this than simply that he didn't want to be known and well known. But why do you think a biography hasn't been written until now? Why has he largely disappeared from the historical record to where an Edwin Hubble is quite famous and he is unknown even to an astronomer who currently occupies
his former office, yeah.
Any further explanation than simply his desire to remain under the radar? How else can you explain this?
Yeah, that's a really important question, and one of the reasons, my wife said to me when I began this project, so I'm writing about a dead white guy at a time when, dead white guys are not really the kind of big thing in the publishing industry. And why write a biography, about him? Why was I curious? And I think part of it is intuitive, part of it is my journalist's nose. And at some point you have to kind of, you don't, if we're talking about Freud and the unconscious, you don't really know fully why are you attracted to this. And so why did his story disappear? We'll start with the personal and kind of move out to the bigger picture. Okay. So he is buried in an anonymous mausoleum slot in Pasadena. He studied, if we go back to the Gary Larson analogy, this cartoonist who, how is the scientist similar to the things they study? He studied stars that were disappearing. These red giant stars, what happens to them over their lifetime is they puff up, they contract, but what he saw, and this was kind of now we're moving into the Stardust part of the story, is when they puff up, what's happening is the elements that they make are getting distributed into space. So these dying stars are like dandelions. They're spreading the seeds of all of these elements that form into, when it gets cooler in the outer edges of the atmosphere, you're beginning to get literally little bits of dust. And some of this dust is carbon dust, and some of the carbon dust is actually molecular dust, things that chemists would think was, that's a sign of life. It's carbon-based, has carbon, oxygen, hydrogen, nitrogen. you're beginning to see this around stars. Paul Merrill didn't, but he saw the dust coming off. And so just to kind of continue that line, when he sent his first papers to journals saying, this was in the mid-1950s, saying that, oh, actually what we're seeing is what's called stellar mass loss, that dandelion analogy. The star is actually pushing out all these elements it's making into space. And this is coming back to the question of, well, why didn't, why wasn't this story told? Why hasn't a biography been written? The journal editor wrote back to him and said, well, how is this possible? Where could it be going? There was no cognitive framework for understanding the idea of stellar mass loss, let alone the idea of stardust ecology, that what happens with all of this dust is it goes on to form other stars and planets. It's basically huge dust motes form in interstellar space. And you can, if you go on and look at the Hubble images, some of the most amazing are of these star nurseries where new stars are being born. Big clouds of dust and gas, like it happens in my apartment, in the corner when I need to clean on, Sundays. That happens in the cosmos. And all of that dust has been made by earlier generations of stars. And Paul Merrill was one of the first to observe this dust being produced. So there was no story framework for it. And it really wasn't another 20 years until Carl Sagan came along that he was like a digital native. He came of age scientifically at a time when scientists could go, oh yeah, stars produce the elements. And he was able cognitively to put that whole story together. So at the time of Merrill's death, this story there wasn't a framework for it. And if he, and I don't know if he kind of sensed the whole story. There's part of me, I'll put in the details that I do know. There are parts of me that, I saw, for example, that when an international spectroscopy organization asked for suggestions about what should be looked for in interstellar space, the space between stars, he wrote H2O, water, which at the time was heretical because astronomers didn't think water could exist in the cosmos. Now we know we live in an ocean, a cosmic ocean. But he crossed it out. And he said, look for hydrogen compounds. So look for things that include hydrogen and oxygen and carbon. And, in terms of interpretation, you could see that as him being actually more curious, because it's like, well, why just look for water when you might find something else? Or you could see him being very conservative and saying, oh, I'm crossing it out because no, that's heretical to say look for water. So that was just, in terms of like why the story kind of wasn't grabbed. I think another big part of it is what I would think about it as cultural resistance. So he's making these major discoveries about our connection with the stars, our evolutionary connection with the stars, in the middle of the 1950s. So if we think back, what's happening in the middle of the 1950s? The McCarthy hearings, the Cold War. It's a time when Americans' relationship with space has this very kind of cutting, like it's not the 1960s when, we're going to go to the moon. It's the 1950s when the Russians are launching Sputnik, when people are doing duck and cover exercises in schools under their desk because we're afraid of nuclear obliteration. What's coming, and you have all these sci-fi movies like Invasion of the Body Snatchers. Our relationship with space is a negative one. We're afraid of what's coming from space, what is possible. And I think, Invasion of the Body Snatchers was like remarkably filmed like a couple of miles down the road from where Paul Merrill lived. And I think that's symbolic because I think that there was a fear-based relationship with space which needed someone like a Carl Sagan with his great, his wonderful sense of wonder and curiosity and personal relationship to kind of change that. But that's now 30 years later, and a lot has changed after the Apollo missions. So there's that fear-based element of space, and then I think another part is that the Big Bang in a cultural sense, like what Hubble discovers, everybody can kind of understand like expanding geography. Oh, the universe got bigger and it's expanding. Okay, that's kind of like a balloon getting bigger. But what Merrill begins to discover about the stars making the elements and the idea of cosmic evolution, this is not long after like the Scopes monkey trials, the anti-evolutionist monkey trials in the 1920s. And in the 1950s, cosmic evolution was in some ways, some of the work was happening in the Soviet Union. American scientists who went to some of these conferences were followed by, by security officials. There was a great, so terrestrial evolution was a culturally contested area. The idea of cosmic evolution, was just off the table. It couldn't really be, I think it was the step too far at the time.
And a generation after Merrill's death, when Carl Sagan becomes one of the great popularizers in science history, that shift has happened, where people are able to grapple with Merrill's discoveries by that time?
Well, I think what's some of the things that are interesting about the way Carl Sagan approaches it, Carl Sagan does it, I don't know if he uses the word evolution in the series Cosmos. Maybe he does. But he talks, Cosmos, a personal journey. It's about his discovery, his relationship with this. And maybe he does talk about it in cosmic evolution, but certainly, why does the story reemerging now? I think that these biographical stories that have been of these hidden figures do emerge for particular reason, or there's interest for particular reasons. So, why women in astronomy? There's a book called The Glass Universe about the women who were computers at the Harvard Observatory at the turn of around the 1900s. That book came out maybe 10, 15 years ago, because women are kind of major players in astronomy now after having been prevented from working at observatories for most of the 20th century, barred from being observers. And so those stories need to be told. And I think with Merrill's story, what I've seen is that hidden figures aren't hidden just because, or there are reasons beyond race and gender. There are also ideological and kind of cognitive reasons that stories aren't told, that can't be held by a culture. And my working title for the book is What We Behold. And I think, so I'm interested both in the sense of what Merrill was able to hold as an individual, but also then when that new knowledge moves into the culture, how the culture receives it. Because one of the things that I found really interesting being in DC and being at the Kluge, talking to people, telling them what I'm doing, when I'm talking about, when I say astrobiology, most people lean in. They're like, astro what? Really? We can think about our relationship with this, our biological relationship with the stars. And then when I say, yes, it's through Stardust, if you look in the dictionary, the primary definition of Stardust is fantasy, magic. It's like in Disney where, Tinkerbell comes out and you see this little falling stars. It's like, oh, this is magic and fantasy but it's not real. But Stardust is real. And we are just at the very beginnings as a culture of absorbing what that means for us, that our ancestors truly are stars.
To understand Paul Merrill, it sounds as if we're going to need to read your book. Tell me when we might. You've been at work with us for some time. You spent quite some time here at the Library of Congress, and it sounds as if there's still some writing to do. When might we be able to read more about Paul Merrill?
Yeah, I've been writing it in a, I call them riffs, little puzzle pieces that I've been putting together as I do the research. And I have a good overarching sense of his story now. I'm hoping, my plan is in the next year to write the book. I don't yet have a publisher for it, so that's a whole other universe, another process, as every author knows. And it's nice to be in a community of authors where of writers here at the Kluge, where it's a circuitous route. So I would say I hope in the next several years, to leave room for mystery, in the next several years, the book about Paul Merrill will be out.
Well, thank you, Jacob Berkowitz. It's been fascinating to talk with you about your writing a biography of a scientist about whom many had never heard, but it sounds as if we should learn more from the life of Paul Merrill. Thank you.
Thanks for your thoughtful questions, Kevin.